Right, welcome back to the Mini Machine Shop. I'm Dave. Not a whole lot's been going on. As you can probably see behind me, there's another monitor. Was a gift from my daughter's boyfriend. That's pretty neat too. It's VGA and DVI inputs. But my laptop, I wanted to connect my laptop up to it just to try it out. But my laptop's only got a HDMI output, so I went on Amazon and found this guy for $12. This is really nice quality too. This is almost like an Apple product. But I love it. You didn't have to install software, didn't have to do anything. It just plugged it straight in to the laptop, into the monitor, poof, everything's there. It also transfers audio, which is nice. They give you a little 2-inch cable, but so the audio comes out of the HDMI and goes into this guy, and they split it off, video and audio. Monitor has speakers. I was surprised because I went and Googled the model, Westinghouse model, just to see what the resolution was of it, and I happened to notice in the specifications it had speakers. I'm thinking, where? So I found the plug on the back of it, the jack for it, plugged into it, and you can barely hear it, and they're tinny too, little teeny weeny speakers. So much for that. So if anybody wants HDMI to VGA, it's only $12, $13 on Amazon. It's really nice too. Got a new Kennedy, 520. It was brand new. Guy had it on Craigslist. I'm looking at this going, this is a machinist that bought this thing, never used it, kept it in the closet, wanted to sell it. I talked him down $180, and it's underneath the bench here. So it came with keys, and yes, Digicon, so I did flitz the keys, and they're all nice and shiny. So yeah, they were really bad. They were badly tarnished, and I actually had to buff one of them because there was a spot that just wasn't coming out. And I happened to make a clamp. It's a nice little guy. But who was it that was having all that? Michael Bashaw. As far as the knurling video that I did, yes, the last math that I showed does work, because I've changed out the knurler wheels with the coarser ones that I have, and I got beautiful coarse knurls. I'm not sure if I can really get that close to see it. Maybe if I can put it up here, it'll focus. So there's the coarse, and this is the fine. So yeah, I've been knurling left and right. So if anybody watches my other video on knurling, part 1 and 2 and take 2, the math is correct and it works fine. Now the video I'm about to do, I'm not sure how it's going to come out, because usually I just start puttering around and then I wind up making something or doing something, and I'm going, oh man, I should have taped that. So I was starting to play around the other day, and it's the result of cold coffee. He watched the video on how I turned different metals and made a comment about runout using the compound. So I had answered back saying that the compound I have, I know there's runout if you're just using the saddle, the full length of the bed. So I just kind of ignored that for the time being and had the compound adjusted so that there's zero runout on it. It accommodates for the other runout. So I started running the camera and starting to play with the other runout, the saddle runout on the whole bed, trying to figure out where it's coming from and what is going on with the lathe. So the video is probably jumpy, because I started it and then I stopped it and I'm jumping all over the place, but when I edit it I'll see how bad it is. But I hope you enjoy it. Mini lathe looking at runout. So alright, different angle for the camera. Let's get this out of here. Alright, like I said, the one comment, I want to see where the runout is, everything on this lathe. This guy, I'm assuming is straight. This just came from Industrial Metal Supply. It's stainless rod. And no matter where I put a micrometer on it, I come up with the exact same reading. I mean, it's just, I don't even see it off by a tenth. And then I'm wondering, I know there's runout in the chuck, but there's all, to really do this, you got to make sure everything is absolutely clean. Because any dirt or contamination in there is going to mess up your readings. And I'll show you. Seems like every time I pull this guy out of the drawer, I go to 0. Look at this, it's 14 thousandths. Now it's 0. 9 thousandths. There's dirt in there. So I've always got to wipe this thing down, and then I'll consistently get a 0 reading. So the slightest bit of grease, lint, whatever, it's going to throw readings off. Alright, let's put this in here, get a dial indicator over here. Oh, compound's in the way. Alright, it's hanging out pretty far. That's tight. That's tight. I'm not going super tight, but I'm going snug. A little bit more than snug. Alright, dial indicator. Alright, drop this guy in there. Oop, flat back. Tighten him up. Oh yeah, you're not going to be able to see the dial in this thing. Alright, bring it up on 0. Exactly 0. Alright, now the compound. I gotta go back further. Yeah, see, it's already moving off. By what? 4.5 thousandths. Alright, bring the compound in, staying on 0. That's up 1,000. Oh, I didn't go all the way back. So I had this adjusted so that, or the rotation, so that there was 0 runout on it. Oh, I'm still on 0. Alright. So it's staying exactly on 0. Still 0. Now it starts to move way out towards the end. So this is probably a gib. It's starting to push it off 1,000th. You just push a little bit here or there and you can change it. It's close to 0. Very close. Where's the high spot? Which way is that? Okay. That's, oh, I can do it manually, Dave. That's the low spot right there. So what happens if I push on it? Or loosen this? Boy, that's tight. Yeah, it doesn't. It's a 1/2,000 runout now, and it's tight. So I guess you can play with these things almost like a 4-jaw chuck and get your runout down. Okay, the length of this thing. Whoa, it's good, way off now. I'm at the extreme end and I'm 9 thousandths. If I come all the way down here, gee, I'm minus 6 thousandths. So if this rod really is straight, something's really crooked here. Well, let me think about this. Okay, hopefully you can see the test indicator. I put that on there because I wanted to see if the bed is tweaked or something. By going on the top, I'll know if it's twisted. But I'm not sure what's now, because I believe the chuck is holding the workpiece at an angle. So as it rotates, you'll see this right here. I think this is the true chuck runout. Which is about 1/2,000. I'll slow that down further. But this is the center of the rotation. If you come down here, it starts getting greater. And it gets really bad. That's, there's a glare in there, I can't see it. That's 1.5 thousandths run out. Then you come, I think everybody can understand what I'm talking about, how it's rotating. And then there's a dead spot, so if I go equally out from that distance there, take that distance and go over here, it should be back to 1.5 thousandths. And it is 1.5 thousandths. So the center here tells me this is the true chuck run out this way on the jaws, but I'm also being held at an angle. Well, after playing around with it, this cannot be straight, because this is definitely the peak right here, and it stays solid. Did that move off the peak? No, it's still on the peak. This was lower, right? Yeah, that's a 1/2 thou. Now it comes up and it's staying at a 1/2 thou. Then all of a sudden it drops way down. Actually, that's going up. So it can't be. This is crooked. Alright, after a lot of screwing around, I did take the stainless rod on the granite block and test indicated it, and yes, it's crooked, and it's matching the 1/2 thousand to 1,000th dips and rises and stuff. So what am I looking for? What I want to figure out is this chuck angled. So I want to know when I'm going from complete end to end, am I actually tapering it? And the only way I can figure out how to do that is to turn it, because the chuck can be holding this way and that way at the same time. So if you turn it, you've actually got an perfectly true surface. Then I can caliper this end and see if the numbers match. So let me go ahead and do that, because I'm going to run the auto feed on this to do it that far, because this only travels 1.5 inches. So I'll come back when I've got it turned. Alright, I finished doing it. It seems like every time you go across it's still taking off material. So I just kept going back and forth here until material stopped coming off, and then same way over here. Took the micrometer, and it looks like this is 14 thousandths smaller than this spot, which tells me this whole thing is cocked this way. So I have 4.6 thousandths taper per inch, and I'm looking at the head and how it's mounted, and I guess this groove here, this rail, is what counts, because there's a groove in the head, and it should be sitting on this face, and this is riding on the same face. So something is really crooked here, and I have a feeling it's when they assembled this part. They've got grease down in there, and it's got this thing cocked this way. So I'm going to try to take it apart and clean that out and see what happens. Try to turn this thing on while I'm holding it, just as I expected. I've already cleaned most of it off. Paint in the grooves from when they were painting it red on here, lots of grease, dirt. Before I even had this bolt tight, and I loosened these two bolts, and I could grab and turn it 5 thousandths, 6 thousandths easy, rotate it. So bingo, I'm just sitting it here, and you can see I can rock it 14 thousandths. That's 0, that's 14 thousandths this way. Alright, so far everything I've done is indicated this thing is twisted this way. I've even test indicated this surface. So I'm pulling it off again. Where's the crest of my Allen wrench go? I hate when you lose stuff like that. Oh, it's down here. So there's two nuts on the front here that you have to remove, and you pull the motor out and get the belt off of it. And there's only one Allen back here. And it's a pain to just try to get it in there, just feeling it. I had it for a second. Here it is. Oh, good, it's loose. Put the Allen someplace, because I'm going to be searching for that again. So there's something someplace that's just keeping this thing cocked towards me. the right ends towards me. Alright, I think I can take the whole thing off this time. Yeah. So this is clean. Because it would be, to push that way, something here. Or something over here. There's no burrs. Well, let me inspect it. Alright, once again it comes down to quality control. Imagine if you just flipped this over and you're looking at the bottom of it. This entire surface, it's a complete surface and it's machined in the V. There's a little piece over here that machined in a V and a little piece over here machined in a V. So I'm picturing it's tilted this way, which means, you know, it's flipped it back the way it is right now. It means there's too much metal here, right? Yeah, the more metal there, it's going to push it this way. Or the more metal over here, it's going to push it that way. So what I tried to do was on the small pieces, file one of them down. And I did take it down, so now the whole back, you can kind of move it. Probably 10, 15 thousandths. But whenever you tighten the two bolts down on the front, it still goes back to a 14 thousandths cock between here and the other end of the rod, the maximum travel on the bed. So that's telling me that this entire face right here is machined crooked. It's machined this way. No. Yeah, it's machined this way. Because when you put it on the bed, it wants to do this number, which pushes that end out. So my only choice was I cut aluminum foil into here, and it took 30 thousandths worth of aluminum foil, just a little stack of it on this end. Now the rod is straight. I don't get any runout on it, but I know it's tilted this thing down, and that's what I've got the dial indicator on the top, and you can see, yeah, it's moving. But the only thing, how much is it moving? I don't do anything that long. So if I'm starting a cut here, that's at 5, 6, that's 7 thousandths. So I'm dropping, that's about my maximum distance, 7 thousandths. I'm dropping 7 thousandths. I don't cut anything longer than that. So the other thing that'll affect is drilling, center drilling it. But I never drill that far out. I'm always way back here drilling. So I actually don't know then where center is. Actually, I could put a piece in here. Yeah, I guess I gotta put it back together. Oh, bet you thought this was gonna be back together. Let me just summarize kind of what I've been doing. I don't think I really was clear with anything. This all started because on the video that I did, machining different metals, someone made a comment. I had mentioned in the video that I was only using the compound, and someone mentioned that there could be a runout issue with that, and I responded saying I was just using the compound only just for this video, but I did know that there was runout along the length of this, and something was crooked. So I figured let me dive into it and see finally what's causing that. Is it the chuck? Is it bearings? Is what? So to take this apart, it's really easy. Take the electronics off. Everything's just quick disconnects except for the safety switch. You undo 2 screws, wires come right out. That's gone. It's a little plastic plate down here. Sits there like that. It's a tab on it, so you got to get it over the lead screw. Pull that out. Now that allows you to get your Allen wrench that comes with the Harbor Freight. There it is, the biggest one that they have. 2 screws, one here, and one here. There's none back here. Oh, you got to remove the motor. There's 2 nuts with lock washers on it. You remove that. Don't touch the 2 gib-looking adjusting screws. Motor, then you can lift it up, get the belt off of it, pop it out of the way so you can access this screw. Pull the screws out, you can take the whole head right off and look at it. And again, I had mentioned that it's this edge right here is machined crooked, and I had put shims in there to straighten it out.
Reason I haven't put it back together is because I didn't mention inside this is all the plastic gears, and there's not one drop of grease, oil, anything on them. This has got a lot of hours on this lathe, and I'm looking at the gears. I think they're Teflon, but they don't look like they're worn at all. So I took an acid brush and coated them really well with some grease and put it back on there. I decided not to put the shim in because I've been doing a lot of work with this, and everything's been pretty precise as it is. And when I test indicated the surface, it was bending it that way a lot. And I think I've been working with it. Most of my work is all done down in this area. I'm just doing small parts. I'm not turning anything huge. I'd rather be on center and straight when I'm drilling a hole through something. And by taking the shim out and putting it all back together, I did test indicate the surface, and it is flat. So there's no, I think there's like a 0.5 tilt to it. But I'd rather leave it this way. So that was the reason behind all this, and that's kind of a summary of what's going on. So I don't know, if you test yours, it's probably the surface. It's another quality control problem, or it could be actually these bearings here. One of them could be shifted, and that's tilting it out. But I'm kind of happy with the way it is. I'm glad I did open it up and put grease in there, because I'm hoping it's going to be a lot quieter now when it runs. I mean, it's like I could hear the difference after grease, just spinning it by hand. So, and I can see why they say, yeah, do not move this high to low speed lever while it's running, because you are going to mess those gears up. They're going to catch. So, also glad I took it apart, because I'm cleaning up all the gears here, re-greasing them, just doing some general maintenance. So, hope you enjoyed. Bye.